29, write the reaction quotient expression for the ionization of NH3 in water. Okay, so we've done tons of work dealing with reaction quotients, right? That's the Q value. So in here, I just dropped down what the Q value is, right? It's just basically concentration of products divided by concentration of reactants, and only aqueous and gases are allowed. Now in this case, I don't see a product and I don't see a reactant because they didn't give me a balanced equation. So the first thing we have to do is we have to make the balanced equation. They told us that NH3 was being added in water. So that means that NH3 is plus H2O, right? And since we're dealing with the reaction quotient, this has to deal with equilibrium. So I know that there's a double line here. Now, how are we going to proceed? This is kind of challenging because it's all resting on one idea. And we have to know that NH3 is ammonia, and that's a base. Now, if you have a base in one of your equations, that other compound is acting as the acid. So this is an acid-base reaction, right? Now, what happens with acid-base reactions? Well, the base is always going to take an extra hydrogen, and the acids are going to lose that hydrogen. Now, remember, this might be a little easier because look at H2O as what its ions are. H2O is really made up of H plus and OH minus, right? If I add H and OH, I will get H2O. So it's this H plus that is going to the NH3. And this is what's going to be remaining. The acid always loses its hydrogen and donates it to the base. So when water, so maybe I'll just write this over here and I'll put it last. It really doesn't matter though. When water loses its hydrogen, it's no longer H2O, it's just OH minus. So I'm just going to erase this and say, okay, I got an OH minus. Now let's do the ammonia side. I have NH3. I'm adding the one extra hydrogen. So if I had NH3, how many hydrogens do I have now? Oh, well, I gained one. So I have 4 hydrogens, NH4. And maybe I'll just make this H a little bit better. And the plus came along with it. So the overall charge of NH4 is a plus. And you should kind of be saying, wait a minute, I know this guy. This is ammonium. This is a polyatomic I had to memorize all the way back in like chapter 2. And same with this. This is hydroxide, polyatomic I had to memorize. So they're all coming back, guys. You will never get away from polyatomics. Anyway. But yeah. So now I have these two in solution. Now I got to worry about the states, right? So there's a little thing here, guys. If you do have charged compounds, if you have ions, right? That's what we're doing. We're doing the ionization, aka making ions, charges. These are always going to be aqueous. So I see a charge, it's aqueous. I see a charge, it's aqueous. Now, liquid is just acting as the, sorry, not liquid. I kind of gave you the answer. Water is acting as the solvent, right? It's just acting as the medium in which the base can do its thing, become an ion. So the water would act as a liquid. And we've seen that, right? Water with acids and bases, it's going to be a liquid. It's not going to be a gas. And since the base is changing, it's ionizing, right? It's going to be aqueous as well. We will get much more in depth into acid-base reactions when we reach that chapter, so hang tight. But as of right now, this is the balanced equation. You could pause the video to make sure that it's balanced, but it is. Now, all I got to do is just write that reaction quotient, right? So here we go. QC is something over something, right? Products divided by reactants. I'm going to use the QC formula here, generally because acid bases are going to be with concentrations. There's no gases here, so I can't use the pressure ones. Okay, and now let's do it. Bracket, we got my 2 aqueous guys, right? NH4 plus, close that bracket, and then I have OH minus, close that bracket. There was, remember, one of each, right? There was one NH4 and one OH minus. You always raise it to the coefficients, but since these are both raised to the 1, who cares, right? It's the same number. And, I just want to reiterate again, only aqueous and gases are allowed in this equation. So I did have an aqueous, that's why it's in there, and this is an aqueous, that's why it's in there. But now if I look at the reactant side, I see that I have an aqueous, but now I have a liquid. Does the water get included in the QC formula? No, it does not, so get rid of it. Bye! We're just going to add this one, right? Water was needed to get the products in the balanced equation, but I'm not going to write that out in the QC formula. And now I just have that reactant, and it's NH3. There's only one of them in the balanced equation, so I can put a 1, but I don't have to. And finally, I have found the reaction quotient expression. And there you guys go. So hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel. That will help us out. And, that will get the word out there in the YouTube universe that this cool service exists. Cool educational content, right? We also got physics. We got math videos. So go check it out, all right? I will see you guys all in later lessons. Have an awesome day.